Welcome to RK International Academy. From this lecture, I will discuss breadth first search, means BFS, in graph data structure. In this data structure is used for basically traversing a graph. Unlike the tree, in tree there is always a source node, which is root. But in graph there is no mention about source node, so we can take any source node at initial. This is our source node, and we will traverse or visit just connected graph, just like level order traversal. First we will traverse this one. This is our 0th level. Second, this 2, 3 and 5, this level, and last this level. So this way we will visit the or fully traverse the with first search or BFS. Here we will maintain a queue for, just because we are using the level order, so we will maintain a queue data structure. And another is array indexes. This is our queue, and another is array indexes, which will be equal to size of the vertex. And initially we will represent all these indexes with false. And then this is our visit, and we will take our result indexes, where this will be our result. And for the source we will represent the U, and destination means another route, means another vertex, which will be V. Now first we will traverse from 1, then it's directly connected with relevant vertex is 2. So first we will 2, then we will check if it's another connected vertex is connected or not, then we will visit 3. Now we will check, is there another vertex which is not visited regarding to 1, so we will visit 5. Then after that we will see the first neighbor which is first visited with regarding to 1, which is 4. So then we will check, is this visited? No, then we will visit this. So first we will visit 1, and by default we always visit at the 0th index, always be 0, 1, 2, 3, 4. It will be true if the queue is not empty. So we will first always push the 0th index or source vertex at the queue, which is 1. Then this is also visited, so we will keep this true, make this true. And then if after visiting the true, we will check if the queue is we pop this, and means this kind of, we will write also pseudocode here. I will keep a queue which is integer type, and visited of source will be true. Suppose this is our source node, so at the index 0 this will be, we keep this true, and after this we will in queue we will push the source node, and then we will check, use a while loop if the queue empty or not. If queue is not empty, then we will maintain another index which is current. In current we will pop this out, so queue.pop. Pop is always operate in the font, so this will be pop, and then we also push this in result of current. So in result index this will be our 1, and then we will check and here we will check if this neighbor of this source element is visited or not. So for this we will use for each loop, for integer x means all neighbors of all neighbors of u. All neighbors of u is visited or not, it will check that. Sorry, not u, current node. Here will be of current is visited or not. Then if not visited, the current node, so now it will if not visited means then it will push its neighbor. First will be 2, after 2 visited, because 2 is not visited, then after visiting it will also make it true. If not visited means 2 is not visited, so then visit of x is equal to true, and it will push q.push of x. Then it will push in, if not visited then it will make true, and then it will push back in q. So if not visited, first it will be true, then it push back in q. Also 3, for 3 it will be true, and then it will push back 3. Also for 5 it will push back, it will make true, and it will push back here. And now it will check. Now again it will go back here. After this it will go back here. After pushing all the concurrent indexes, it will come here and it will check if the queue is empty or not. Queue isn't empty, so first it will pop out. So it will first pop out in current, and then it will also push back here, means it will be 2. Also now when 2 will be pop out, it will check if its neighbor is visited or not. If not visited, then choose neighbor is not visited, so also it will be first true here, and then it will push back in queue. Then there is no neighbor, so it will go back to again while loop, and then it will check if 3 is visited. Also 3 is also it will check queue is empty or not. If queue isn't empty, then queue will be pop out in current, and it will pop out, and then it will go to result, and it will check if there is a visited, there is neighbor of 3. No, there is no neighbor in 3, so it will go back in while. So after going while, it will again check if queue is empty or not. Queue isn't empty, so this will pop out into current. So now it will push back in 5, and then it will check if there is any neighbor of 5. No, there is no neighbor, so it will again go to while and check if queue is empty or not. Queue isn't empty, so it will pop out the 4 from queue, and then it will go back to, it will push this 4 in result. So output, this will be our output. This will be our output, and if there is no, now when it will go back, when it will see that queue is empty, so it will leave from the, it will return. I have opened the VS Code editor, where I create a file name bfs bfs.c++. Now include iostream, and we also use to store the data is vector, and for BFS we also use the queue, and using namespace std and int main function, and we will create a BFS function where we will pass the vector and a boolean, which will be represented with visited, and also we will store the value and now we will create a queue, and first we will visited, the source will be true, and then we will push the source in result, sorry, not result, in queue. First we will source the source in queue, and then we will go to loop while Q isn't empty. In current, we will Q dot font and then Q dot pop for the popping out from the queue. Then we will push the value in result, push back of current, and now it will check the every neighbor is visited or not. Int x of current adjacency list of current. If not visited, if not visited of x, then first it will visited of x will be true, visited of x will be true, then it will push back in queue. Now there we will create another function which is void at h where it is the vector of int of adjacency and int u and int v for source and destination node, and that adjacency of u dot pushback of v, and also adjacency of v dot pushback of u. And then in main function we will create a vertex v is equal to 5 and at h where we'll pass the adjacency list and then source value where is 1 and 1 and 2, then at also like adjacency of And now we will pass the value in vector. We create a result, and now we will create a result vector in result is equal to bfs of adjacency, bfs of adjacency list. We pass this to create the adjacency list, and then this is for the printout, and x for every result, every element in result. See out the x. Now we will create another function. Name is bfs. I hope you can relate this code with the theory diagram which we have discussed in written. From this, we just calculate the size of how many vertex is there. Then vector boolean boolean where number of vertex at initial will be false, and then vector of integer of result will be stored here, and then for int I is equal to 0 for the traversing all the vertex until I less than equal to v I plus plus, and if not visited I, then bfs connected and adjacency of I comma visited and result. This will be pass. I is for the source node and visited for the true or false if the node is visited or not for checking that. And in result we will store here, and at last we will return the result. Little mistake, small mistake, I have corrected those. And here is the BFS connected graph, and this function is created if there is this function is created. So to handle and disconnected graph, and this edge it will create the adjacency list, and here's the main function, and here it will be here it will output our value. Now let's run this. And I think there is some issue here. I have started this from 1, so the vertex will be v plus 1. So this was the mistake. Now I have run this, and this is our output 0, 1, 2, 3, 5, and 4. So thank you for watching.